Here's an introduction to experiment 10, the synthesis of potassium alum. So what we're doing here is we are making a solid product that's known as an alum. It's down here, this solid product. So it's always made up of monovalent, so a +1 cation, a trivalent cation, which is a +3, and then it has to have a sulfate also. And once again, like we've seen before, this .12 waters means that there are 12 waters absorbed into this crystal structure of the alum. And what we're beginning with in this reaction is aluminum, and that's going to be our limiting reactant in this equation and reaction. So we're going to add several other things, potassium hydroxide, sulfuric acid along the way. It's a multiple step reaction. But these are kind of the two key points that we need to know about, is that the aluminum is what we're starting with. That's our limiting reactant. And then our alum is the product that we're forming. In the video, you'll see the procedure, and you can read it here. You'll be completing the pre-lab, and I'll go ahead and show you that here in the pre-lab shows you the overall balanced equation for the reaction, which is important because once again we're starting with a known amount of aluminum and we're figuring out how much of the alum we should make so that we can figure out our percent yield. So what you'll be doing is calculating the theoretical yield of alum, and I'll go ahead and label this as alum, based on how much aluminum you use in your reaction. You'll notice that it's a 2 to 2 mole ratio, which really is the same as a 1 to 1 mole ratio. So when you get here, your notes will remind you of this, but you're going to skip this optional instructor demo. And the video will give you these data points. So you'll be given the amount of aluminum that was used. So the calculations that you'll be doing here to find the theoretical yield of alum is you'll start with your grams of aluminum that we just talked about, the amount of aluminum used. You'll convert that to moles of aluminum using the molar mass. And then using the balanced equation, you'll go mole to mole to the product, and remember that's a 2 to 2 mole ratio or a 1 to 1. And then lastly, you'll go to grams of alum. Remember when you're adding the molar mass here to make sure to add in those waters that are absorbed into the crystal structure, and you'll see those in the compound's formula. I'll refer back to that really quickly. Right here you'll add up a potassium and aluminum, 2 sulfates, and 12 waters. So that's how you'll find the theoretical yield for the alum, how much you should form. You'll also be given the mass of an empty filter paper and cup, and then also the alum filter paper and cup so that you can subtract. So you'll subtract these two to find how much alum you actually made. This will be your actual yield. So for percent yield, you'll put your actual, which is number 4, over your theoretical, which is number 5, times 100. And then you'll be given the melting points. And you'll answer the rest of the questions and the post-lab questions.